this video, we're going to talk about some of the first differentiation rules, and the first one being the power rule. So what I have is, how do we take the derivative of x to a power without doing the limit definition? So what was proven with the limit definition is to take the derivative of x to a power. You bring down the power in front as a coefficient, and then subtract 1 from the exponent. So this is our power rule that we want to go ahead and memorize. So let's go ahead and do a couple examples using that rule. So if I had, for example, f of x equals x to the 6th, then the derivative is 6x to the 6 minus 1, which is the same thing as 5. So usually what we do is we just write 6x to the 5th. Now I purposely wrote bad notation, and let me show you the bad notation. You guys see how we have the original function and it goes equals, equals, but this isn't the original function anymore. The second you start taking a derivative, you want to write this notation. So this should be the first thing that you write when you take a derivative, f prime of x. So we're telling everybody, this is the derivative, people. Here we go, and that's my answer. So the derivative of x to the 6th is 6x to the 5th. All right, let's do a couple others. What if I had x to the 12th? Then the derivative of x to the 12th is 12x to the 11th. That's the whole thing. Woo woo. All right, so here people start getting cocky and they think, ooh, this is so easy. Okay, what if we had the square root of x? Notice I also wrote y. Okay, so you can have y's, you can have f of x, you can have g of x, and all the good stuff. So the first thing we'd want to do is recall that the square root is the same thing as an exponent of a half. So I've not taken a derivative yet. This is still the original function. I'm just rewriting it. Okay, so let's go ahead now and take the derivative. So when I take the derivative, so there's my prime notation, I get 1/2 x to the 1/2 minus 1. So 1/2 minus 1 is the same thing as x to the negative 1/2. Awesome. Now a lot of students try to leave it in that form. You want to go ahead, and it's kind of like polite mathematics, that if they gave it to you in roots, you should rewrite it in roots. So that negative means that it's going to be in the denominator, and that is saying it's going to be a square root in the denominator. So what we really have is 1/2 square root x. All right, let's do 2 more quick examples. So let's come over this way. All right, so if I had g of x equals the cube root of x. All right, so the cube root is the same thing as x to the 1/3, so I'm still writing the original function is x to the 1/3. Now I'm going to take the derivative using the power rule. So 1/3 x to the 1/3 minus 1. 1/3 minus 1 is the same thing as x to the negative 2/3. Okay, now let's go ahead and take a few more steps to rewrite this. All right, so this would be the same thing as 1 over x to the positive 2/3 in the denominator. Okay, the denominator of this fractional exponent says the kind of root it is, so it's going to be a cube root. That's telling me what's going to be underneath the house. So what's going to happen is this is 1/3 times 1, the cube root of x squared in the denominator. And then what I typically do is just squish it together. So when I squish it together, I get a little bit of a mess. Boom, boom, boom. There it is. Okay, now notice that I did not write g prime of x all the way down the side. That is totally fine, assuming it's right there. It's implied. If this is g prime of x here, it's now implied that all of this that follows is in fact the derivative, okay? So sometimes students get confused about, well, Jen, do I need to write it every single time? Yes. The second you're taking a derivative, you want to write it. If you want to write it again as like a final statement that, boom, this is g prime of x, you're welcome to it. But as long as you write it at the top saying that this whole thing is the derivative, we're good to go. All right. In the next video, we'll talk about the next rule.